Hello my friends, and welcome back to the You Can Do TV channel. The John Deere H414 harvester head is designed for mid-size to large harvesters, making it ideal for late thinnings and regeneration harvesting. It features an excellent power-to-weight ratio and high maneuverability. The feed roller arms have built-in guards, strong cylinders, and well-protected hose routings for durability. The head is equipped with 4 moving delimbing knives, a fixed top knife, and a fixed back knife, ensuring precise delimbing by following the contours of the stem. The knive's long cutting edges provide exceptional delimbing quality across various stem diameters. The Supercut 100 saw unit allows a maximum felling diameter of 620 millimeters, making the H414 suitable for diverse forestry applications. Pacific Veneer, a peeler mill in Aberdeen, Washington, specializes in producing high-quality veneer used for plywood manufacturing. The production process transforms whole logs into thin wood sheets in a matter of seconds, ensuring maximum material utilization and minimal waste. Log preparation and debarking. The process begins in the log yard, where carefully selected logs are loaded onto the debarking deck. The debarker removes bark to prepare the logs for cutting. Next, they are sent to the cutoff saws, where they are cut into standard-sized blocks, typically 103 1/4 inches in length, cooking and peeling. The blocks are transferred to vaults for steaming, a process that lasts approximately 16 hours. Steaming softens the wood fibers, making it easier to peel. Once conditioned, the blocks enter the lathe infeed, where an advanced charger system determines the optimal XY center for maximum recovery. The blocks are then fed into a lathe, where they are peeled into continuous veneer ribbons. Sizing and sorting. The veneer ribbons move to a rotary clipper which scans for defects and trims the sheets accordingly. To ensure proper drying, veneers are sorted by moisture content. Keeping the veneers organized prevents over-drying or the need for re-drying, which maintains quality and efficiency. Drying and grading. The veneers pass through an industrial dryer, operating nearly continuously for 6.5 days a week. By the time they exit, they must have a moisture content of 8% or less. The dried sheets are then graded by a Ventex system and sorted into bins. Packaging and distribution. Once graded, the veneer sheets are strapped, banded, and stored in a dry environment before being shipped to plywood mills. Depending on customer requirements, the veneer may be used for underlayment, sheathing, or various other plywood products. The Tandem eucalyptus bandsaw is designed specifically for high-efficiency cutting of eucalyptus logs, which are known for their density and toughness. This machine operates with 2 synchronized bandsaw units working in tandem, ensuring precise and continuous cutting with minimal material waste. The process begins with log feeding, where the eucalyptus logs are aligned and transported to the cutting section. The first bandsaw makes an initial cut, reducing the log to a manageable size, while the second bandsaw further processes it into planks or boards. The tandem configuration improves cutting accuracy and speed, making it suitable for high production environments. The saw blades are made of high-strength alloy steel, with specialized tooth geometry to withstand the hardness of eucalyptus wood. A lubrication and cooling system ensures smooth cutting while preventing blade overheating. Additionally, automated controls allow for precise thickness adjustments and consistent output. The Tandem eucalyptus bandsaw is widely used in sawmills and timber industries. offering increased productivity, reduced waste, and high-quality lumber suitable for construction and furniture applications. The production of large barrels at Tunneleri Arable follows a specialized process. The selection and preparation of wood are crucial steps, ensuring high-quality raw materials. This expertise is passed down through generations, with knowledge transferred directly from experienced craftsmen. Each barrel is uniquely crafted by a team of 2 or 3 specialists, adapting to specific capacity requirements. The manufacturing process takes place in modern, spacious facilities in Barrett, designed to accommodate large-scale production. The workshop allows for the construction of barrels and vats entirely indoors, optimizing working conditions. Skilled craftsmen assemble the barrels, carefully shaping the staves and securing them with metal hoops. The wood undergoes controlled bending and toasting processes, which enhance its durability and influence the aging characteristics of the stored liquids. Recent advancements have enabled the production of 6 350 hectoliter barrels, reflecting the company's expanded capabilities. With distribution managed by Tunneleri Sauri and Leroy, arable barrels are now supplied to major wine regions worldwide, reinforcing its reputation for excellence in cooperage. The production process at Idaho Forest Group, IFG, is a highly efficient and technologically advanced operation, designed to maximize the use of every tree while maintaining sustainable forestry practices. The process follows a structured series of steps to transform raw logs into high-quality lumber and other wood products. Log procurement and sorting. IFG sources logs from private, state, and federal lands, prioritizing sustainable forestry management. Upon arrival at one of IFG's sawmills, logs are sorted based on species, size, and quality. This sorting process ensures that each log is utilized for the most appropriate end product. Debarking and scaling. Once sorted, logs are fed into a debarking machine which removes the bark while preserving as much of the wood as possible. The bark is repurposed for biomass energy or landscaping materials. The logs are then scaled to measure volume and assess quality, helping optimize cutting patterns for maximum efficiency. The primary breakdown sawing logs proceed to the primary breakdown phase, where they enter a head rig or bandsaw that makes the initial cuts. Advanced scanning technology analyzes each log's shape and internal structure, determining the most efficient sawing pattern to maximize recovery and minimize waste. The log is then positioned for optimal cutting and guided through the saw using precision controls. Depending on the size and species of the log, it may pass through multiple saws to produce rough lumber of various dimensions. Circular saws provide fast, high-volume cutting, while bandsaws offer finer, more precise cuts. Curve sawing gangs adjust dynamically to the natural curvature of the log, improving yield by reducing unnecessary waste. Some logs may also pass through chipper canters, which remove the outer wood to produce cants, rectangular blocks of wood that are further processed into lumber. The primary breakdown phase is a crucial step in ensuring efficient material utilization and product quality. Edging and trimming. After the primary breakdown, rough-cut boards move through an edging machine, which trims off irregular edges to create uniform, standard sizes. The trimmed material, such as sideboards and offcuts, is either repurposed for secondary wood products or converted into chips for pulp and paper production. Before proceeding to the drying phase, the edged and trimmed lumber undergoes a quality control inspection. This process includes both automated machine inspections and manual checks by skilled workers to identify defects, ensure proper dimensions, and verify the overall quality of the boards. Any boards that do not meet quality standards are redirected for reprocessing or downgraded for alternative uses, ensuring optimal utilization of raw materials. Drying, kiln and air drying. Once cut to size, lumber must be dried to reduce moisture content and improve stability. IFG utilizes both air drying and kiln drying methods. Kiln drying accelerates the process by using controlled heat and airflow to achieve the desired moisture level. This step is critical for preventing warping, shrinking, and fungal growth in the final product. Planing and grading. After drying, the lumber passes through a planer mill to create smooth, consistent surfaces. Automated grading systems, often utilizing machine vision and laser scanning, inspect each board for defects, strength, and appearance. The lumber is then sorted into various grades, such as structural, appearance, or industrial use. Packaging and distribution. Once graded, the finished lumber is stacked, bundled, and packaged for shipment. IFG ships its products to national and international markets, catering to construction, furniture making, and other industries. Additional byproducts, such as wood chips, sawdust, and bark, are also utilized for secondary markets, including bioenergy and landscaping materials. The production process of Karlı wood chairs begins with the selection of high-quality plywood and solid wood materials. The wood is chosen based on its durability, grain quality, and sustainability. Plywood, known for its strength and versatility, is used for chair seats, backs, and armrests, while solid wood is employed for structural components. For molded plywood components, the cut plywood sheets are layered with adhesives and placed in high-pressure presses. The press applies heat and pressure, shaping the plywood into curved forms such as chair backs and seats. This step ensures that the final product maintains structural integrity and ergonomic comfort. After pressing, the molded plywood components undergo fine machining to refine their shape and smooth any rough edges. CNC drilling machines create precise holes and joints required for assembly. This step ensures a seamless fit between different chair parts. Once the materials are selected, they are cut into precise dimensions using CNC machining centers and lathes. The 5-axis CNC machining centers allow for complex cuts and intricate detailing, ensuring consistency and accuracy in each chair component. The wood is then shaped into the desired form using molding techniques. The chair components are then meticulously sanded to remove any imperfections and prepare the surface for finishing. Multiple grades of sanding are applied to achieve a smooth, polished texture. This step is crucial for ensuring an even and high-quality finish. Once all components are prepared, they are assembled using high-precision joinery techniques. Depending on the design, the chairs are either glued, screwed, or doweled together to ensure durability and stability. Skilled craftsmen carefully inspect each piece to ensure a perfect fit before moving to the finishing stage. The assembled chairs go through a finishing process which includes staining, painting, or lacquering. Paint booths are used to apply coatings evenly, enhancing the chair's aesthetics and durability. Finishing also provides protection against moisture and wear, extending the lifespan of the furniture. For upholstered chairs, the upholstery workshop takes over, adding cushioning and fabric or leather covers. High-quality padding materials are used to provide comfort and longevity. The upholstery is precisely cut and stitched to fit each chair's design perfectly. Each chair undergoes rigorous quality checks to ensure it meets Karlı's high standards. Inspectors examine structural stability, surface finish, and overall craftsmanship. Any defects are corrected before the chairs proceed to packaging. The finished chairs are carefully packed using protective materials to prevent damage during transportation. Each unit is labeled and prepared for shipment, ensuring on-time delivery to customers. In rural Romania, Wood splitters play a crucial role in ensuring an efficient and steady supply of firewood, which remains a primary heating source in many households, especially during the harsh winters. Traditional manual splitting methods are labor-intensive and time-consuming, making modern hydraulic wood splitters essential for farmers and villagers. These machines significantly reduce physical strain and increase productivity, allowing users to process large quantities of wood quickly. Beyond domestic use, split firewood is often sold in local markets, providing an additional source of income for rural families. Wood splitters also contribute to sustainable forestry practices, as they allow for efficient use of felled trees, reducing waste and optimizing firewood production. Wood splitters work by using hydraulic pressure to force logs against a wedge, splitting them into smaller, manageable pieces. A typical hydraulic wood splitter operates with a force of 10 to 30 tons, depending on the model. For example, a 20-ton splitter can handle logs up to 24 inches, 60 centimeters, in length and 12 inches, 30 centimeters, in diameter, cutting through hardwoods like oak and beech effortlessly. Cycle times range from 10 to 20 seconds per split, allowing for rapid processing. Some models include vertical and horizontal operation modes, increasing versatility for different log sizes and user preferences. This homemade firewood processor in New Zealand is a practical solution for efficiently cutting and splitting firewood. Many DIY enthusiasts build portable firewood splitters using hydraulic rams, chainsaws, and conveyor systems to streamline the process. These machines can be trailer-mounted for easy transport and are ideal for rural properties. Custom-built designs often focus on affordability, durability, and ease of operation. In Norway, an impressive homemade 30-ton log splitter roars to life. Built with a powerful cylinder repurposed from a container truck, this beast doesn't just split logs, it now features a brand new knife that shreds wood into 12 pieces in one strike. But the innovation doesn't stop there. Now equipped with a conveyor, it swiftly transports split logs into bags or away from the work area. The combination of raw power and efficiency makes this DIY project a game changer, turning heavy-duty wood splitting into an almost effortless task. The Targo 3000 XD processes green waste and other residual materials using a 3-meter-long shredding shaft with 21, optional 41, replaceable teeth. A specialized 3-stage gear transmits power from the diesel direct drive to the shaft, ensuring efficient material breakdown. The machine features steep side walls to prevent material bridging and an integrated overload protection system to safeguard against damage from foreign objects. A self-propelled crawler chassis enables mobility on rough terrain, while the extended discharge conveyor allows for large stockpiles and direct truck loading. The Scorpion 350 SDB is a drum chipper designed for processing wood waste up to 250 millimeters in diameter. It features a large loading throat, 375 by 340 millimeters, allowing efficient feeding of bulky branches. The wood intake system includes a toothed roller and a conveyor belt, both hydraulically driven for smooth operation. A 2-knife drum ensures high efficiency, and a sieve, 30 by 30 or 50 by 50 millimeters, ensures uniform chip size. Powered by a 74.8 HP diesel engine, it includes a no-stress system to prevent overload, enhancing productivity and machine longevity. The Arjes VZ 750 shredder efficiently processes tree trunks using its dual-shaft design with a patented T-blade profile. The hydraulic drive delivers high torque, ensuring smooth shredding even for large and dense wood. Two tilting hoppers guide the tree trunks onto the tool shafts, where the rotating blades cut the material into smaller pieces. The automatic reversing function prevents tool fractures by detecting blockages and adjusting the shaft rotation accordingly. The shredder operates at a low noise level due to its insulated engine housing and optimized speed. Available in stationary, semi-mobile, and mobile versions, it offers versatility for different work environments while maintaining low maintenance and wear costs. The development of sawmills in Canada and their economic role. Sawmills have played a crucial role in Canada's economy since the early days of European settlement. The first sawmills were established in the 17th century along rivers, using water power to process logs into lumber. By the 19th century, steam-powered mills allowed for increased production, and the construction of railways facilitated the transportation of timber to domestic and international markets. Today, modern sawmills use advanced automation, high-speed cutting equipment, and computer-controlled systems to optimize efficiency and reduce waste. Canada's sawmill industry is a major contributor to the national economy. The country is the second largest exporter of softwood lumber globally, with the industry employing over 90,000 people directly and supporting thousands more in related sectors. In 2023, Canada produced approximately 64 million cubic meters of softwood lumber, with British Columbia, Quebec, and Ontario being the leading producers. The industry is integral to rural communities, where sawmills provide stable employment and support local economies. Modern sawmills operate by processing logs into dimensional lumber through a series of automated steps. First, logs are debarked and sorted by size. Then, they enter a primary breakdown unit, where bandsaws or circular saws cut them into rough boards. High-efficiency sawmills can process over 100,000 board feet per shift, depending on the mill's capacity. Advanced scanning and optimization systems ensure minimal waste. With wood chips and sawdust repurposed for pulp production, bioenergy, or wood pellets. With ongoing investments in sustainable forestry practices and mill automation, Canada's sawmill industry continues to be a global leader, balancing economic benefits with environmental stewardship. The wooden chair production process at CM Cadiras begins with wood selection, where each board undergoes thorough inspection to eliminate defects such as cracks and knots. To achieve optimal working conditions, the wood is dried in specialized greenhouses, maintaining a humidity level between 10% and 14%. This drying enhances stability and durability. Once prepared, the wood is processed using high-precision machinery, ensuring uniformity in all components. CNC machines with 6-axis capabilities perform cutting, milling, and drilling operations with extreme accuracy. For curved elements, presses shape the wood using prefabricated molds. After shaping, each piece is sanded using specialized sanders for a smooth and homogeneous surface. The assembly stage relies on manual craftsmanship to ensure precise fitting of components. Corner blocks are added for reinforcement, preventing structural failures. Each chair undergoes labeling for traceability before moving to the finishing stages. The painting process, carried out manually, ensures uniform color distribution. A retouching phase follows, involving careful sanding to refine the surface. Varnishing is executed by a 5-axis robotic system for a consistent finish. The chairs are then placed on a conveyor belt for controlled drying. Upholstery, where applicable, is applied manually to guarantee a perfect fit. Finally, the chairs are carefully packed using protective materials and labeled for accurate shipping to customers worldwide. The building process of a sofa at England Furniture begins with frame construction. Each frame is crafted from 3/4 and 7/8 inch frame-grade plywood, reinforced with hardwood for durability. Computerized routers ensure precision cutting and interlocking joints for structural integrity. Guide notches assist in accurate assembly. Next, the spring system is installed. England Furniture uses a high-quality seat support system with double spring reinforcement at each end and perpendicular wires running across the spring surface. This setup minimizes seat wear and ensures long-term comfort. Unlike competitors, England places the perpendicular wires beneath the springs to prevent chafing. The arm construction incorporates heavy-gauge cardboard, nearly twice as thick as industry standards, reinforcing the frame for added stability. The padding process follows, where durable fiber barriers and denim fabric cover the seat deck to enhance comfort. Back support is reinforced with high-grade polyester fiber fill, encased in baffled bags to prevent fiber migration. Cushions consist of foam wrapped in a thin layer of sheeted fiber, ensuring longevity. Hidden zippers allow fiber adjustments for personalized comfort. The final assembly includes quality control checks before shipping. This handmade mechanical wood splitter is powered by a 2.2 kilowatts electric motor and utilizes a WD-200 reducer to control speed and torque. Power is transmitted through a system of pulleys, Phi 270, 200, and 2x120, and a 17mm V-belt, ensuring smooth and efficient operation. The machine works by rotating a splitting cone or wedge, which progressively drives into the wood, forcing it apart along its natural grain. The reducer optimizes torque, allowing the splitter to handle various wood sizes. This prototype, though unfinished, demonstrates effective mechanical splitting, reducing manual effort and increasing efficiency compared to traditional methods. The Petzolato VSP60 is a combined firewood processing machine designed for large diameter logs. It features a fully hydraulic and manual control system. The machine cuts logs up to 600 millimeters in diameter using a high-performance circular saw. After cutting, logs are automatically transferred to the integrated splitter, which handles diameters up to 700 millimeters with a splitting force of 20 tons. Powered by an 18.5 kilowatts electric motor, a 100 HP diesel engine, or a 60 HP tractor, the VSP 60.60 ensures efficient and precise firewood production, making it ideal for large-scale operations and firewood preparation. This wood processor with a hydraulic shear and splitter is a machine designed for efficient firewood production. Logs are fed into the processor, where a hydraulic shear cleanly cuts them to length, eliminating the need for a saw blade. The cut log then moves to a hydraulic splitter, which forces it through a wedge, splitting it into firewood. The hydraulic system provides high pressure for smooth cutting and splitting, making the process fast and efficient. The Samokvalov System Wood Splitter is an industrial hydraulic double-acting machine designed for high-efficiency wood processing. It can split logs up to 30 centimeters in diameter into 8 pieces in one direction and any diameter logs in half on the return stroke. Powered by either a Lifon 15 horsepower gasoline engine or a 4 kilowatts, 380 volts electric motor, It ensures versatility. Optional features include a lift system and trailer attachment. The John Deere 1910E Forwarder operates efficiently in Finnish forests, transporting logs with a 21-ton load capacity and a boom reach of up to 8.5 meters. Its 249 HP engine delivers 220 kilonewtons of tractive effort, ensuring smooth navigation over rugged terrain. The Intelligent Boom Control IBC system provides precise log handling with electrical end damping, reducing impact forces. Quang Pat Wood, located in the North Dong HOI industrial area, Thuan Du Commune, Dong HOI City, Quang Binh Province, specializes in producing high-quality plywood. The manufacturing process follows strict technical standards to ensure durability, aesthetic appeal, and eco-friendliness. The process begins with the selection of plantation wood, with a minimum diameter of 12 centimeters. These logs are cut to precise specifications before undergoing a filtering process to remove defects. The cuticle is then thinned into veneer sheets using specialized machinery, ensuring uniform thickness and smoothness. The resulting veneers typically range from 1 mm to 2.5 mm in thickness and are available in various sizes. Once the veneers are prepared, they are dried using a rouleau dryer at a controlled temperature. This process, lasting approximately 24 hours, reduces the moisture content to a range of 6% to 10%, ensuring stability and preventing warping. After drying, the veneers are sewn together to form larger sheets, which are then prepared for bonding. The bonding process involves the application of glue between the veneer layers using an automated glue spreading machine. This ensures even distribution and strong adhesion, forming the plywood structure. The glued sheets then undergo both cold and hot pressing under regulated pressure and temperature, ensuring optimal strength and structural integrity. Moisture content is maintained between 10% and 12%, and each board is assessed for mechanical properties, flatness, and overall quality to meet customer specifications. Once pressed, the plywood undergoes surface treatment to enhance its aesthetic appeal and usability. Sanding and preliminary cutting refine the boards before the core is attached to additional veneer layers or customized surfaces as per client requirements. The boards then proceed through another round of cold pressing, hot pressing, fine sanding, and final trimming. A thorough quality inspection is conducted on each plywood board to ensure compliance with industry standards. The finished products are then branded with the Quang Phat Wood mark, accompanied by complete documentation verifying their origin and quality. The production of high-quality doors at Wesmark Mega Factory follows a 17-step process, integrating advanced German engineering and precision manufacturing. The process begins with beam saw cutting for accurate sizing, followed by 6 spindle molding for precision shaping. Corporal slitting applies premium Italian veneers, while door layup incorporates imported particle board core. Calibration sanding ensures smooth surfaces, and flat lamination enhances durability. Resizing and rebating are performed with automated high-precision equipment. Next-gen edge banding strengthens edges, followed by CNC machining for intricate designs. U-frame and jamb assembly create a seamless structure, Reinforced strike plates and final hardware assembly complete the doors, ensuring superior strength and aesthetics. The production process of luxury leather furniture at Mascaroni is a blend of traditional craftsmanship and modern technology, ensuring the highest quality and durability. The process begins with the careful selection of raw materials, primarily premium full-grain bovine hides and high-quality solid wood. The hides, sourced mainly from Europe, undergo a detailed tanning process, preserving their natural characteristics and enhancing their longevity. Wood components are precision cut, shaped, and assembled to form the sturdy internal structure of furniture pieces. Skilled artisans then upholster the frames using Mascaroni's signature thick leathers, which can range up to 4 millimeters in thickness. This step involves intricate hand stitching and precise tailoring to ensure a flawless fit and finish. Each product is assembled by hand, with experienced craftsmen overseeing every stage of the process. Advanced machinery assists in cutting and shaping materials, but the final assembly and finishing rely heavily on handcrafting techniques. The leather is stretched, sewn, and carefully fitted to maintain its natural texture while ensuring long-term durability. Strict quality control is conducted throughout the production cycle, with each piece undergoing thorough inspections for structural integrity, aesthetics, and functionality. The result is a luxurious, handcrafted product that combines traditional expertise with contemporary design, making each Mascaroni furniture piece unique and built to last. The production process of a sofa at Classic Leather, a division of Century Furniture, begins with sustainably sourced materials, primarily from within 500 miles of Hickory, North Carolina. Plywood for upholstery frames, compliant with CARB and TSCA-VI standards and SFI certified, is cut and assembled in the upholstery factory. Over 50% of the hardwood, grown in sustainably managed U.S. forests, is shaped into sturdy frames using advanced woodworking equipment. The frame fabrication involves precise machining to ensure durability and fit. Next, cushions are crafted with polyfoam containing high soy oil content, reducing petroleum use, and wrapped in fiber from recycled materials. Inner springs and metal banding, incorporating recycled steel, are integrated for support. Skilled artisans then upholster the frames with leather or one of over 2,500 fabric options, applying detailed stitching and trims. Finishing involves low VOC, nitrocellulose lacquers with high solids content, ensuring a durable clear coat. The completed sofa is packaged primarily in SFI-certified U.S. cardboard, with over 40% recycled content, preparing it for shipment from the Hickory facility. Each step reflects a commitment to sustainability and craftsmanship. The Panto router uses a pantograph mechanism with a 2-to-1 ratio, where a guide bearing follows a template, cutting mortises and tenons with precision. The same template is used for both cuts, ensuring perfect fit. It supports various joinery types, including dovetails and box joints, with fast. India's decorative veneer industry is experiencing notable growth, driven by the expanding real estate and interior design sectors. In 2023, the market was valued at approximately $249.7 million United States dollars and is projected to reach $376.3 million United States dollars by 2033, reflecting a compound annual growth rate (CAGR) of 4.2%. Teak remains the dominant wood species in this segment, with its valuation expected to hit $197.4 million United States dollars by 2033. The residential sector is a significant contributor, accounting for 57.2% of the market share in 2023. Geographically, West India is anticipated to hold a substantial share of around 31.9% by 2033. In the broader context, India's door market was valued at $10,209.3 million United States dollars in 2021 and is forecasted to reach $16,370.39 million United States dollars by 2031, growing at a CAGR of 4.8%. Wooden doors, particularly those made from teak, are highly favored due to their durability and aesthetic appeal. In 2023, teak accounted for over 32% of the door market share. India's significant consumption is evident, with approximately 1.8 million cubic meters of teak imported and around 500,000 cubic meters produced domestically in 2023, culminating in a market value of about $2 billion United States dollars. Regarding high-pressure laminate doors, while specific production figures for India are limited, the Asia-Pacific region, including India, held a 41.23% share of the global decorative HPL market in 2024, valued at $2,640.64 million United States dollars. This figure is expected to rise to $3,525.23 million United States dollars by 2032. The manufacturing process of fiberboard begins with debarking, splitting, and chipping roundwood. The wood chips are screened to separate fine and coarse material, retaining the useful fraction. After washing, the chips undergo pre-steaming and are compressed by a plug screw feeder to remove excess water. They are then boiled in steam at approximately 175 degrees Celsius before being refined into fibers. Adhesives and additives are sprayed onto the fibers in the blow line, followed by drying in a flash dryer. The dried fibers are then formed into a mat, pre-pressed, and subjected to hot pressing to create the final fiberboard. Laboratory-scale production allows precise testing of recipes and process settings before industrial manufacturing, ensuring consistency and optimal material properties. The Pezolato PTH 1300M is a powerful drum chipper designed for high-capacity wood processing. It features a conical-shaped feeding opening and a fully opening upper roller, enabling efficient intake of bulky logs and branches. The roller feeding system eliminates foreign objects, reducing wear on the cutting knives and enhancing operational longevity. The chipping process relies on a closed drum with staggered sections, equipped with knives, a counter knife, and an interchangeable calibration grid. This setup ensures precise and consistent wood chip sizes by maintaining a fixed cutting length. A collapsible counter knife minimizes damage from accidental non-wood debris. After processing, wood chips are transported via 2 rubber belts, which deposit them in a linear fashion, significantly reducing dust production and maintenance needs. The machine's large drum diameter and low rotational speed allow it to produce wood chips of various sizes. The EEP ZSH 45 mag screw chipper efficiently processes wood into coarse chips with minimal fines. Powered by a 310 kilowatts diesel engine, it features a 47 by 47 centimeters inlet opening. The cylindrical screw mechanism pulls in logs and branches, chipping them with a controlled cutting action. This results in uniform, coarse wood chips, ideal for applications like wood gasification and biomass energy production. Its stationary design ensures robust performance. The SH25EG auger chipper was a prototype designed to produce energy wood chips for combined heat and power plants. It featured a conical auger mechanism that fed and chipped wood in a continuous process. The auger pulled in logs, breaking them down into uniform chips without the need for additional feeding mechanisms. However, this technology was experimental and later abandoned in favor of more efficient chipping methods. Despite its potential advantages, such as simplicity and fewer moving parts, it was ultimately not adopted for large-scale use. This wood chunker efficiently cuts wood into uniform chunks for gasifiers, making it ideal for wood-burning vehicles. Consistent chunk size ensures better gasification, improving engine performance. These machines use rotating blade shears to process logs, branches, and scrap wood. The Arjes Raptor XXL-DK efficiently shreds tree logs using its robust shredding system. The process begins as logs are fed into the machine's large hopper. The material moves towards the shredding chamber, where two massive 3-meter-long shafts, made from wear-resistant steel, rotate powerfully. These shafts are fitted with precisely arranged shaft discs and knives, optimized for wood processing. As the shafts rotate, the logs are gripped, fractured, and broken down into smaller pieces. The paddle shaft design ensures effective material intake while preventing clogging. The cutting process continues as the knives on the shafts slice through the wood, reducing it into manageable fragments. Worn knives can be refurbished, ensuring sustained performance. To control the final output size, the shredder features adjustable side combs. These can be mechanically or hydraulically adjusted, depending on the machine model, to regulate the grain size. Once shredded, the processed wood exits the chamber, ready for further use or disposal. The Arjes quick change system enables efficient maintenance, allowing easy replacement of worn shredding shafts, minimizing downtime, and ensuring continuous operation in demanding applications. The production process of glued laminated timber glue-lump structures at Upholstered follows a precise and highly automated workflow, ensuring accuracy and efficiency. Material selection and preparation. The process begins with the selection of high-quality spruce timber, which is dried to a moisture content of 12% plus or minus 2%. This ensures stability and durability of the final product. The raw wood is planed, calibrated, and visually or mechanically sorted based on quality criteria. Lamination and gluing. Once prepared, individual lamellae are coated with adhesive and assembled into the required shape. The bonding process is carried out using high-performance adhesives that provide strength and long-term durability. The laminated timber is then pressed using specialized presses, including curved presses for the production of arch trusses. Curing and machining. After pressing, the glued laminated timber undergoes a curing phase to achieve full adhesive strength. The cured components are then precisely machined on CNC-controlled processing centers, such as the CMS PMT Portal Processing Center and Hundegger cutting machines. These machines execute precision cuts, milling, and drilling based on CAD data. Customization and assembly preparation. Each structural element is processed according to detailed specifications, including exact dimensions, drilled holes, and joint details. Upholstered ensures millimeter precision, allowing seamless on-site assembly. Additional treatments, such as water-based impregnation, are also available to enhance durability. Quality control and logistics. Before dispatch, each component undergoes rigorous quality checks to ensure it meets structural and aesthetic standards. The processed elements, including gable roof trusses and arch trusses, are then packaged and delivered directly to the construction site as a ready-to-assemble kit. On-site assembly. Once delivered, the timber components fit together seamlessly, significantly reducing construction time. The prefabricated elements enable rapid installation, with entire timber structures assembled in as little as 4 to 5 days. At CM Tekisa's wooden chair factory, 5 CNC machines work simultaneously on chair components. The 6-axis CNC machines ensure precision in delicate tasks, enabling cutting, milling, and drilling with exceptional accuracy. This advanced automation guarantees consistency, enhances efficiency, and maintains high-quality standards in every piece produced, optimizing the manufacturing process for durability and design precision. The production process at Orca Factory begins with high-quality raw material selection, including moisture-resistant MDF and engineered wood. Precision cutting is performed using advanced CNC machines to ensure accuracy in panel dimensions. Surface finishing, such as laminating and painting, follows to enhance durability and aesthetics. Automated drilling and assembly lines ensure efficient component integration, while edge banding machines provide seamless finishes. Quality control inspections are conducted at each stage to maintain consistency. Final assembly includes hardware installation before rigorous testing. Packaging is optimized for safe transportation, ensuring that finished bathroom furniture meets international quality standards before dispatch. Papa Thorne's homemade wood splitter and wood tumbler are ingenious DIY creations designed for efficient firewood processing. His wood splitter is a robust, custom-built machine that utilizes a hydraulic ram to split logs effortlessly. Mounted on a sturdy steel frame, it features a powerful engine and a wedge that cleanly splits wood with minimal effort. This setup allows for quick and consistent splitting, making firewood preparation easier. Complementing the splitter, the wood tumbler is a rotating drum made of steel mesh that removes debris, bark, and smaller wood chips from the freshly split logs. As the logs tumble, loose material falls away, leaving behind clean firewood ready for stacking or burning. Powered by an electric motor or a simple belt-driven system, the tumbler significantly reduces manual labor. The production process at Deschholz begins with the delivery of round timber, where logs arrive at the sawmill for processing. The logs are first debarked using advanced machines like the Valencone debarker. The removed bark is then processed into bark mulch, which is utilized for landscaping or biomass applications. Once debarked, the logs proceed to the round timber cutting stage, where they are cut using a gather saw with automatic width adjustment. This allows for precision in producing various timber dimensions. The sawn wood is then sent for sorting using automated conveyor systems to separate boards, beams, and other timber products based on size and quality. The facility also features an energy generation system that powers the drying kilns, ensuring that the wood reaches optimal moisture content. The dried timber can then be processed further using a profiling planer for smooth finishing. For wood requiring heat treatment, a signature marking process ensures compliance with IPPC standards. The processed timber is then cut to precise lengths using package crosscut saws and optimized using optimization crosscut saws to minimize waste. To enhance durability, certain products undergo immersion impregnation for increased resistance against environmental factors. The processed elements are then used in element construction and joinery for various structural applications. The final steps include loading the sawn timber and wood chips for distribution. This ensures efficient logistics and on-time delivery to customers. Deschholz also operates a KVH production facility, which began operation in early 2021, producing structural timber in various standardized dimensions. Additional services include custom cutting, planing, heat treatment, and drying, making Deschholz a comprehensive supplier for high-quality timber products. The Pezzolatto TLC 1100 is a highly versatile firewood processing machine designed for handling medium to large logs, ensuring efficient cutting and splitting. Equipped with a hydraulically driven cut disc unit and an integrated log splitter, it allows a single operator to manage the entire process seamlessly. The operator can control key parameters such as cut length, splitting grid settings, scrap management, and log loading through a centralized control panel. A key enhancement in some installations, such as Angelini Truck and Wood, is the integration of the ST triple log splitter. This component significantly boosts productivity by incorporating 3 independent loading hoppers. The operator can simultaneously process logs of different sizes, drastically reducing processing time and increasing output. The TLC 1100 efficiently handles both individual logs and bundled logs of varying diameters, making it suitable for diverse applications. Whether producing large firewood for domestic use or smaller firewood for pizzerias, this machine ensures optimal performance with minimal labor.